Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/JEDI. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam LTAM. It comes from the last exam MLC from spring 2018. For a whole life insurance of $100,000 on a 45-year-old, you are given that gross premiums of $900 are paid every half a year. The death benefit is paid at the end of the half a year of death. Mortality follows the illustrative life table. Interest rate is 5%. Renewal expenses are 10% of the gross premium. Deaths are uniformly distributed between integer ages. The gross premium reserve at duration 10.5 immediately before the premium payment is 10.5 VG equal to 16,074. Calculate the gross premium reserve at the end of the 11th policy year, 11 VG. By the way, note that the interest rate, valuation interest rate, is different than the rate used in the illustrative life table because the rate used in the table is 6% and the rate in this problem is 5%. And here's the solution. We write out the recursive reserve formula from policy duration 10.5 till policy duration 11. So going from policy duration 10.5 to policy duration 11 over half a year. The reserve at time 10.5 is 16,074 plus gross premium after expenses, 900 times 0.9. After 10% expenses are taken out, that's accumulated at 5% over half a year, 5% effective annual rate, and that gives us death benefit for those who die, and probability of dying is 0.5Q 55.5 times 100,000 for the expected payout for those who die, and the rest is the reserve at policy duration 11, but only for those who live, so multiplied by 0.5p 55.5. Under uniform distribution of deaths, the population size at age 55.5 is exactly the average of the population at age 55 and age 56. From the illustrative life table, we look up L55 to be 8,640,861 and L56 to be 8,563,435. And the average of the two is L55.5, so it's 8,602,148. And that means that the probability of surviving from age 55 to 60, which is 0.5p 55.5, is L66 divided by L55.5, and that's 8,653,435 divided by 8,602,148, and it's approximately 0.99549961. And using that information, we can write out what the probability of survival is, and 1 minus that is the probability of dying. And now, as you can see, the only unknown in here is 11 VG, which is what we're looking for, and it has to be equal to 16,074 plus 0.9 times 900 accumulated at 5% over half a year minus 100,000 times 1 minus 0.99549961 divided by that probability of survival of 0.99549961. And when we calculate this, this comes out to be approximately 16,927.09, which is answer A. Please remember, this is copyrighted material. The problem itself belongs to a society of actuaries. The solution is mine. Good luck in your studies and good luck on the test.